Since prehistoric times, people have taken note of the moon's phases, its waxing and waning, and used it to keep record of time. Tally sticks, notched bones dating as far back as 20–30,000 years ago, are believed by some to mark the phases of the moon. The counting of the days between the moon's phases gave eventually rise to generalized time periods of the full lunar cycle as months, and possibly of its phases as weeks. Of particular significance has been the occasion of full moon, highlighted and celebrated in a range of calendars and cultures. Around autumnal equinox, the full moon is called the harvest moon and is celebrated with festivities such as the Harvest Moon Festival of the Chinese lunar calendar, its second most important celebration after Chinese New Year. Furthermore, association of time with the moon can also be found in religion, such as the ancient Egyptian temporal and lunar deity Khonsu. Since prehistoric and ancient times, humans have depicted and interpreted the moon, particularly for astrology and religion, as lunar deity. Iconographically, the crescent was used in Mesopotamia as the primary symbol of Nana, Sin, the ancient Sumerian lunar deity, who was the father of Inanna, Ishtar, the goddess of the planet Venus, symbolized as the eight-pointed star of Ishtar. And Utu, Shamash, the god of the sun, symbolized as a disk, optionally with 8 rays, all 3 often depicted next to each other. Nana was later known as Sin, and was particularly associated with magic and sorcery. The crescent was further used as an element of lunar deities wearing headgears or crowns in an arrangement reminiscent of horns, as in the case of the ancient Greek Selene or the ancient Egyptian Khonsu. Selene is associated with Artemis and paralleled by the Roman Luna, which both are occasionally depicted driving a chariot, like the Hindu lunar deity Chandra. The different or sharing aspects of deities within pantheons has been observed in many cultures, especially by later or contemporary culture, particularly forming triple deities. The moon in Roman mythology, for example, has been associated with Juno and Diana, while Luna being identified as their biname and as part of a triplet, Diva Triformis, with Diana and Proserpina, Hecate being identified as their binding manifestation as Trimorphos. The perception of the moon in modern times has been informed by telescope-enabled modern astronomy and later by spaceflight-enabled actual human activity at the moon, particularly the culturally impactful lunar landings. These new insights inspired cultural references, connecting romantic reflections about the moon and speculative fiction such as science fiction dealing with the moon. Contemporarily, the moon has been seen as a place for economic expansion into space, with missions prospecting for lunar resources. This has been accompanied with renewed public and critical reflection on humanity's cultural and legal relation to the celestial body, especially regarding colonialism, as in the 1970 poem, Whitey on the Moon. In this light, the moon's nature has been invoked, particularly for lunar conservation and as a common. The lunar effect is a purported and proven correlation between specific stages of the roughly 29.5-day lunar cycle and behavior and physiological changes in living beings on Earth, including humans. The moon has long been associated with insanity and irrationality. The words lunacy and lunatic are derived from the Latin name for the moon, Luna. Philosophers Aristotle and Pliny the Elder argued that the full moon induced insanity in susceptible individuals, believing that the brain, which is mostly water, must be affected by the moon and its power over the tides, but the moon's gravity is too slight to affect any single person. Even today, people who believe in a lunar effect claim that admissions to psychiatric hospitals, traffic accidents, homicides or suicides increase during a full moon, but dozens of studies invalidate these claims. The moon is Earth's only natural satellite. It is the 5th largest satellite in the solar system and the largest and most massive relative to its parent planet, with a diameter about 1/4 that of Earth, comparable to the width of Australia. The moon is a planetary mass object with a differentiated rocky body, making it a satellite planet under the geophysical definitions of the term and larger than all known dwarf planets of the solar system. It lacks any significant atmosphere, hydrosphere, or magnetic field. Its surface gravity is about 1/6 of Earth's at 0.1654 grams, with Jupiter's moon Io being the only satellite in the solar system known to have a higher surface gravity and density. Orbiting Earth at an average distance of 384,400 kilometers or about 30 times Earth's diameter, its gravitational influence very slowly lengthens Earth's day and is the main driver of Earth's tides. The moon's orbit around Earth has a sidereal period of 27.3 days. During each synodic period of 29.5 days, the amount of visible surface illuminated by the sun varies from none up to 100%, resulting in lunar phases that form the basis for the months of a lunar calendar. The moon is tidally locked to Earth, which means that the length of a full rotation of the moon on its own axis causes its same side to always face Earth, and the somewhat longer lunar day is the same as the synodic period. However, 59% of the total lunar surface can be seen from Earth through shifts in perspective due to libration. The most widely accepted origin explanation posits that the moon formed 4.51 billion years ago, not long after Earth, out of the debris from a giant impact between the planet and a hypothesized Mars-sized body called Theia. It then receded to a wider orbit because of tidal interaction with the Earth. The near side of the moon is marked by dark volcanic maria seas, which fill the spaces between bright ancient crustal highlands and prominent impact craters. Most of the large impact basins and mare surfaces were in place by the end of the Imbrian period, some 3 billion years ago. The lunar surface is relatively non-reflective, with a reflectance just slightly brighter than that of worn asphalt. However, because it has a large angular diameter, the full moon is the brightest celestial object in the night sky. The moon's apparent size is nearly the same as that of the sun, allowing it to cover the sun almost completely during a total solar eclipse. Both the moon's prominence in Earth's sky and its regular cycle of phases have provided cultural references and influences for human societies throughout history. Such influences can be found in language, calendar systems, art, and mythology. The first artificial object to reach the moon was the Soviet Union's Luna 2 uncrewed spacecraft in 1959. This was followed by the first successful soft landing by Luna 9 in 1966. The only human lunar missions to date have been those of the United States Apollo program, which landed 12 men on the surface between 1969 and 1972. These and later uncrewed missions returned lunar rocks that have been used to develop a detailed geological understanding of the moon's origins, internal structure, and subsequent history. It is believed by some that 20–30,000-year-old tally sticks were used to observe the phases of the moon, keeping time using the waxing and waning of the moon's phases. One of the earliest discovered possible depictions of the moon is a 5,000-year-old rock carving Orthostat 47 at Knowth, Ireland. The ancient Greek philosopher Anaxagoras reasoned that the sun and moon were both giant spherical rocks, and that the latter reflected the light of the former. Elsewhere in the 5th century BC to 4th century BC, Babylonian astronomers had recorded the 18-year Saros cycle of lunar eclipses, and Indian astronomers had described the moon's monthly elongation. The Chinese astronomer Shi Shen gave instructions for predicting solar and lunar eclipses. In Aristotle's description of the universe, the moon marked the boundary between the spheres of the mutable elements earth, water, air and fire, and the imperishable stars of ether, an influential philosophy that would dominate for centuries. Archimedes, 287–212 BC, designed a planetarium that could calculate the motions of the moon and other objects in the solar system. In the 2nd century BC, Seleucus of Seleucia correctly theorized that tides were due to the attraction of the moon, and that their height depends on the moon's position relative to the sun. In the same century, Aristarchus computed the size and distance of the moon from Earth, obtaining a value of about 20 times the radius of Earth for the distance. Although the Chinese of the Han Dynasty believed the moon to be energy equated to qi, their radiating influence theory recognized that the light of the moon was merely a reflection of the sun, and Jing Fang, 78–37 BC, noted the sphericity of the moon. Ptolemy, 90–168 AD, greatly improved on the numbers of Aristarchus, calculating the values of a mean distance of 59 times Earth's radius and a diameter of 0.292. Earth diameters were close to the correct values of about 60 and 0.273 respectively. In the 2nd century AD, Lucian wrote the novel A True Story, in which the heroes travel to the moon and meet its inhabitants. In 499 AD, the Indian astronomer Aryabhata mentioned in his Aryabhatiya that reflected sunlight is the cause of the shining of the moon. The astronomer and physicist Alhazen, 965–1039, found that sunlight was not reflected from the moon like a mirror, but that light was emitted from every part of the moon's sunlit surface in all directions. Shen Kuo, 1031–1095, of the Song dynasty created an allegory equating the waxing and waning of the moon to a round ball of reflective silver that, when doused with white powder and viewed from the side, would appear to be a crescent. During the Middle Ages, before the invention of the telescope, the moon was increasingly recognized as a sphere, though many believed that it was perfectly smooth. In 1609, Galileo Galilei used an early telescope to make drawings of the moon for his book Sidereus Nuncius, and deduced that it was not smooth but had mountains and craters. Thomas Harriot had made, but not published such drawings a few months earlier. Telescopic mapping of the moon followed. Later in the 17th century, the efforts of Giovanni Battista Riccioli and Francesco Maria Grimaldi led to the system of naming of lunar features in use today. The more exact 1834-1836 Mappa Selenographica of Wilhelm Beer and Johann Heinrich Madler, and their associated 1837 book Der Mond, the first trigonometrically accurate study of lunar features, included the heights of more than 1,000 mountains, and introduced the study of the moon at accuracies possible in earthly geography. Lunar craters, first noted by Galileo, were thought to be volcanic until the 1870s proposal of Richard Proctor that they were formed by collisions. This view gained support in 1892 from the experimentation of geologist Grove Carl Gilbert, and from comparative studies from 1920 to the 1940s, leading to the development of lunar stratigraphy, which by the 1950s was becoming a new and growing branch of astrogeology. Humans have been active around and on the moon for more than half a century, having sent a wide range of missions to the moon, having stayed robotically and with people, leaving many traces and having set up temporary moonbases. The moon remains a challenging and particular environment. The only instances of humans living on the moon have taken place in an Apollo lunar module for several days at a time, for example, during the Apollo 17 mission. One challenge to astronauts during their stay on the surface is that lunar dust sticks to their suits and is carried into their quarters. Astronauts could taste and smell the dust, calling it the Apollo aroma. This fine lunar dust can cause health issues. In 2019, at least one plant seed sprouted in an experiment on the Chang'e 4 lander. It was carried from Earth along with other small life in its lunar micro-ecosystem. Isotope dating of lunar samples suggests the moon formed around 50 million years after the origin of the solar system. Historically, several formation mechanisms have been proposed, but none satisfactorily explains the features of the Earth-Moon system. A fission of the moon from Earth's crust through centrifugal force would require too great an initial rotation rate of Earth. Gravitational capture of a pre-formed moon depends on an unfeasibly extended atmosphere of Earth to dissipate the energy of the passing moon. A co-formation of Earth and the moon together in the primordial accretion disk does not explain the depletion of metals in the moon. None of these hypotheses can account for the high angular momentum of the Earth-Moon system. The prevailing theory is that the Earth-Moon system formed after a giant impact of a Mars-sized body, named Theia, with the proto-Earth. Giant impacts are thought to have been common in the early solar system. Computer simulations of giant impacts have produced results that are consistent with the mass of the lunar core and the angular momentum of the Earth-Moon system. These simulations show that most of the moon derived from the impactor, rather than the proto-Earth. However, more recent simulations suggest a larger fraction of the moon derived from the proto-Earth. Other bodies of the inner solar system such as Mars and Vesta have, according to meteorites from them, very different oxygen and tungsten isotopic compositions compared to Earth. However, Earth and the Moon have nearly identical isotopic compositions. The isotopic equalization of the Earth-Moon system might be explained by the post-impact mixing of the vaporized material that formed the two, although this is debated. The impact would have released enough energy to liquefy both the ejecta and the Earth's crust, forming a magma ocean. The liquefied ejecta could have then re-accreted into the Earth-Moon system. Similarly, the newly formed Moon would have had its own lunar magma ocean. Its depth is estimated from about 500 kilometers to 1,737 kilometers. While the giant impact theory explains many lines of evidence, some questions are still unresolved, most of which involve the Moon's composition. Above a high-resolution threshold for simulations, a study published in 2022 finds that giant impacts can immediately place a satellite with similar mass and iron content to the Moon into orbit far outside Earth's Roche limit. Even satellites that initially pass within the Roche limit can reliably and predictably survive, by being partially stripped and then torqued onto wider, stable orbits.